In this lecture, you will learn the following: how to handle vertical motion. A lot of people say that G should be plus G while going down and minus G while going up. That is not so. It is always minus G. And then you will do some great questions on 1D motion that not only test your understanding but also build your understanding. And finally, we'll understand circular motion. There is always a centripetal acceleration, but there could be a second acceleration as well. Welcome to the portals of real learning. Listen carefully and don't skip at all. So now we go to the concluding session of this chapter called 1D motion. In the last session, we discussed the equations of motion. These are the four equations, and these are only valid when the acceleration is constant. Otherwise, we have to use calculus, which is beyond the scope of 9 standard. So we only deal with problems where the acceleration is constant. We also derived all these four equations first by the graphical method and then by the analytical method. All right. Now let's proceed. Applying this equation, suppose we have a situation that the body starts from rest. That means u equal to 0. So the equations become u is 0, so v is 80, s is half 80 square, and v square is 2as. The fourth equation was s equal to u plus v by 2 into t. Since u is 0, it becomes only vt by 2. Suppose body has a retardation, that means acceleration is opposite to the velocity. And let's assume that the initial velocity was not 0. Suppose u was 0 and there's an acceleration, then it would be called only acceleration because there's no initial velocity. It won't be a deceleration now. Even if the acceleration is downwards, let's say minus, since the u is 0, the v will also be downwards and v will keep on increasing. So it's very important to realize that acceleration is negative when it is opposite to the velocity. If the initial velocity itself is 0, then the velocity after a small time would be along the acceleration. So then the speed will only increase. Now, in the case that u is not equal to 0 and the acceleration is negative minus a, then v will become u minus 80, s will be ut minus half 80 square, and v square will be u square minus 2as because we replace a with minus a, right? Acceleration due to gravity is called g, has got a certain value, and it is always downwards, no matter what the velocity of the body, no matter what the mass of the body. It is independent of those two things. If the body is thrown up, then there is a retardation because acceleration is opposite to the velocity. And therefore, the body stops after reaching some height. After that, it starts falling down. This time, the speed will keep on increasing because the initial speed was 0. G or minus G? It is always minus G. Many textbooks will tell you to take G as negative when the body is moving up and to take it as positive when it is coming down. It is not incorrect, but it is confusing. Acceleration due to gravity is constant in magnitude and direction. Why should its sign depend on where the body was going initially? So the G is always minus G. When it is coming down, the speed itself, the velocity itself is minus. That means A and B are parallel to each other, and hence the speed keeps on increasing. So always take the acceleration as minus G, right? Take this case that a body is projected up with the speed u, then it will reach a certain height and then its speed becomes 0 and stops there momentarily. So u is positive, A is minus G, and h, the displacement, is positive. So we can use here s equal to ut plus half at square, s is plus h, u is plus u, and a is minus g. A is minus g. Therefore, h will be ut minus half gt square. Similarly, v square is equal to plus u square. In any case, you are squaring, so minus will become plus. Plus 2 AS it is, but A is minus G and S is plus H. At the highest point, the V is 0, that is U square minus 2GH. Therefore, the maximum height that it goes up to is U square by 2G. And what is the time of ascent? At the highest point, the speed is 0, so U minus GT. And therefore, the time of ascent is U upon G. And suppose it is dropped from a certain height, U is 0, it is going down. So the S is minus H and the A is minus G. So minus H is equal to half into minus GT square. This minus minus cancels and H is equal to half GT square. And the time for it to fall down is root 2H by G. Please make a note of these equations. Okay. Let's do some problems once again. And then we'll go to circular motion and then conclude the session. A car acquires a velocity of 72 kilometers per hour in 10 seconds starting from rest. Find the acceleration, the average velocity, and the distance traveled in this time. So U is 0, B is 72 kilometers per hour, and I've already told you to remember that 36 kilometers per hour is equal to 10 meters per second. Therefore, 72 kilometers per hour is 20 meters per second, and the time is 10 seconds, right? So there is an acceleration because it went from 0 to 20 meters per second. And in what manner it happened, that is not given as such. Okay. So the velocity went to 20 meters per second in a time equal to 10 seconds. So we can talk of the average acceleration, that is final velocity minus initial velocity divided by the delta t. Final is 20, initial is 0, so 20 divided by the time 10, 2 meter per second square, that is the average acceleration. Whether the acceleration was constant throughout or not constant is not given. We can calculate the average. Okay. And average velocity now will be how much? So we have already obtained an average acceleration that is 2 meter per second square. And now we can say that for the entire time 10 seconds, it was going at this average acceleration. So then the average velocity will be initial plus final by 2. Initial is 0, final is 20 by 2 is 10 meters per second. So it is average velocity is 10 and the time is 10, so it is 100 meters. If you consider ut plus half at square, then u is 0, so it is only half a t square. A is 2 and t is 10, so we get the same answer. Now let's look at the type of acceleration from this question. The distance in centimeter covered in each second by three objects A, B, and C is given. In the first second, in the second second, third, fourth, fifth, what is the distance covered by each of the bodies is given in the table. Which object is moving with constant speed? Constant speed means equal distances in equal times. This is the distance in the first second, 20 centimeters. In the second second, also 20. So in all the seconds, it is 20 centimeter for A. So A is covering equal distances in equal times. That guy has a constant speed. But B and C don't have a constant speed because the distance traveled in each second, they are different, 20, 36, 24, etc. For C also it is different. Second question, which object is moving with a constant acceleration? Okay. The velocity from 0 to 1 second is how much? It covered 20 centimeters in the first second. Therefore, the average velocity was 20 centimeter in that second. Now, in the second second, that is from 1 to 2, it covered 36 centimeters, right? And the third second from 2 to 3, it covered 24 centimeters. We are talking of B, right? So the velocity is going from 20 to 36 and down to 24. It has got an irregular acceleration. And if you look at object C, then that guy has got a constant acceleration, because in the first second it covers 20 centimeter, in the second second it covers 60 centimeters, and in the third second it covers 100 centimeter. So the increase in speed was 20 to 60, 40 centimeter per second, and later on 60 to 100. So in each second, the velocity is increasing by the same amount, 40 centimeter per second, and that is regular acceleration or constant acceleration. So answer for 2 is C, and answer for 3 is B. Answer for 1 was A. Okay. A ball is initially moving with a velocity of 0.5 meter per second, and it decreases at a rate of 0.05 meter per second square. How much time will it take to stop, and how much distance will the ball travel before it stops? So let's write down what is the initial velocity, 0.5. Acceleration is minus 0.05 because the velocity is decreasing. It's a retardation. And the final speed is 0 because it is stopping. Time. If you want to know the time, we got the V, U, and A. So obviously we should use this equation to find the time. V is 0, U is 0.5, A is minus 0.05, T is therefore minus this zero point 0.5 will go this side, minus zero point 0.5 divided by minus 0.05. This cancels, and that is 10 seconds. And how much distance is covered? If I apply this one, final speed is 0, initial speed 0.5 square plus 2, but A is minus 0.05 into S. Again, 0.5 square will go this side with a minus sign, so S is minus 0.5 square divided by 2 into 0.05 is zero point 0.1, so therefore it becomes 0.5 square is minus minus cancels, 0.25 divided by 0.1 is 2.5 meters. Uniform acceleration. There is a body with uniform acceleration. It travels 84 meters in 6 seconds and 264 meters in 11 seconds. Find the initial velocity and the acceleration. The acceleration is given to be constant. We have to find how much it was. After 6 seconds, it has covered 84 meters. After 11 seconds, it has covered 264 meters. The initial speed is unknown. So we can use this equation because acceleration is constant. For time t equal to 6, s is 84, right? U is unknown, but time is 6, so 6u plus half. A is unknown, and then t square, that is 6 square, right? So 6 square is 36, and 2 will cancel with 36 and make it 18. Furthermore, we divide by 6, so this becomes 3, and divide 84 by 6, we have 14. So 14 is equal to u plus 3a. That's one equation. And then let us apply the same equation for 11 seconds. The s is 264, t is 11, and here 11 square. That gives me another equation in u and a. So equations 1 and 2 are available to us. Two equations, two unknowns, we can easily solve for it. If we subtract 2 minus 1, then 24 minus 14 is 10. U will cancel when we are subtracting. 11a by 2 minus 3a, that is 5a by 2. Therefore, 2 goes here and 5 cancels with this 10. Acceleration is 4 meter per second square. Once we have acceleration, we can substitute this in equation 1. U is 14 minus 3a, a is 4, so 14 minus 12, u was 2 meter per second. So learn to set up equations from the given data. And if you have two unknowns to be found out, you have to have two independent equations. Okay. A ball is thrown up vertically. It goes to a height 19.6 meters and then comes back to the ground. What was the initial velocity? What was the total time of the journey? What is the final velocity of the ball? Take G as 9.8. Now we have already derived h equal to u squared by 2g, right? So u is a velocity with which it is thrown up. It goes up to a certain height and then it stops momentarily. To find the initial velocity, we have h is given to us and v is obviously 0. So we can use v square equal to u square plus 2as. V is 0, u square plus 2 again, a is minus g. And the h is positive because it is going up. It's a displacement that is going up. So u square is equal to 2gh, 2gh. That is u square. And if you take the square root of this, then this 19.6 actually is 2 into 9.8, right? If you take a square root of all this, then 1 2 will come out and 1 9.8 will come out. U is 19.6 meters per second, and that is the answer for question 1. Time of journey, time of ascent is U by G, right? So U is 19.6 and G is 9.8. So 2 seconds to go up and 2 seconds to come down. So total time of journey will be 4 seconds. Guys, please note that time of ascent is equal to the time of descent if we ignore air resistance. Final velocity of the ball when it strikes the ground, well, it will be the same magnitude but downwards. So same as U but downwards, and 19.6 meter per second is a speed and the direction is downwards. Okay, so those were all the aspects of 1D motion. Now let's discuss a little bit about circular motion. This is not 1D really, but let's just talk about it a little bit. Okay, when the velocity is changing, we say the body is accelerating because acceleration is the rate of change of velocity. Velocity may change on two accounts, either the magnitude changes or the direction changes or both magnitude and direction changes. Important to realize that even if the speed is constant, the direction may change and then the velocity has changed and therefore there is an acceleration like in the case of circular motion. Now let's learn about circular motion and the acceleration involved over there. Suppose an athlete is going around a track at constant speed. The track is of different shapes. At every bend, he has to change his direction. He is going at a constant speed. So, suppose I have tracks of various kinds of shapes and sizes. If I talk of the triangle, he starts from here, goes like this, and then at this point, he has to do a bending. Then at this point, he has to do a bending. And at this point, he has to do again a bending. And then one cycle is completed. So when it is a triangle, he changes his direction 3 times. If it is a rectangle, he'll have to change the direction 4 times. If it is a hexagon, he'll have to change his direction 6 times in one cycle. If it is like a 10-sided polygon, he has to change his direction 10 times. So if I increase the number of sides of the polygon 10, 20, 50, 100,000, then it is approaching a circle. How many times does he change his direction? In this case, he has to change his direction all the time, continuously, because the number of sides of the polygon in the case of a circle is actually infinite. Every single polygon side is very tiny, very tiny, very tiny, very tiny. We are increasing the number of sides of the polygon and decreasing the length of each side of the polygon. In the limiting case, the number of sides goes to infinity and the size of each part of the polygon tends to 0. It becomes a circle. And that means he's continuously bending, and that means there's a continuous acceleration. There is an acceleration at every instant. If you talk of a triangle, the acceleration is only at this point when the direction changes. Then again at this point, then again at this point, 3 times. In the case of a rectangle, 4 times, right? In the case of a circle, continuously. So what is the acceleration then? Acceleration in uniform circular motion. That means the speed is constant, but the velocity is changing. The velocity at any instant is tangential. So let's say here velocity is v1, here it is v2, here it is v3, v4, v5. I have drawn the length of the arrow same to indicate that the speed is constant. That is, the magnitude of the vector is constant, but the direction is clearly changing, right? And therefore the velocity is changing and there is an acceleration. What is the direction and magnitude? Now, if you look at this animation of a body going around in a circle at a constant speed, the blue arrow that you see over here is the velocity vector at that instant. It is always tangential. Tangential means perpendicular to the radial vector that is drawn. You can see the black arrow, which is a radial vector. The velocity is always perpendicular to the radial vector. And the speed is constant. You can make that out, right? So let me take these two instants, velocity v1 and here velocity v2. So I've drawn velocity v1 and this velocity v2 is tilted by some angle. v1 is the initial velocity, v2 is the final velocity. Their magnitudes are equal, so the length of these two yellow arrows is the same. v2 is final. Final is initial plus the change. Initial plus the change. The change will be like this. Delta V is like this, which is pointing towards the center. And as we know, since A is equal to delta V by delta T, the direction of the acceleration is along the change velocity vector, along delta V, not along V1, not along V2. It is along delta V. And delta V is toward the center. Hence, we call it centripetal acceleration, meaning seeking the center. Centripetal means seeking the center. So the acceleration in a uniform circular motion is centripetal. It is always directed toward the center. And there is a continuous acceleration because continuously it is changing its direction. So the acceleration at this point is toward the center. That's a vector. At this point, it is toward the center. At this point, it is again toward the center. The acceleration itself is changing because the acceleration is a vector. Its direction is changing. Whether the magnitude is changing or not, that you will see, but clearly the direction is changing. Therefore, the acceleration vector is also changing. It is always directed towards the center. That is true. But the direction in space is always changing. Velocity is always changing, continuously changing. Acceleration is also continuously changing. The magnitude of velocity is constant. If the magnitude of the velocity is constant, and that is what we call uniform circular motion, then the magnitude of the acceleration is also constant. Magnitude is constant, direction keeps changing. Like this kind of a motion occurs when if you tie a stone to a string and rotate the string in a horizontal circle, and if the string were to break at this instant, then the ball will flow along the red arrow because that was the direction of the velocity at that particular instant, which is tangential. I may as well write down that the magnitude of the acceleration is equal to the magnitude of the speed square divided by the radius. So make a note of this. The magnitude of the acceleration is constant if the speed is constant, but the direction of the acceleration is always changing. Just as an aside, just as a corollary, if it is a non-uniform circular motion, that means the speed itself is changing. Just like when you switch on your fan, the fan starts like this, slowly, slowly, then the speed increases, right? During the time that the speed was increasing, only during the time that the speed was increasing, there was a centripetal acceleration because every point on the fan is going on a circle. Centripetal acceleration will be there. But since the speed is also changing, there'll be a second acceleration. which is called tangential acceleration. Just as a corollary, what that is, we don't need to discuss that at this level, but at least you should know for a uniform circular motion, we have a centripetal acceleration whose magnitude is v squared by r, whose direction is toward the center. Finally, let's conclude this with a question on a circular motion. A satellite is moving in a circular orbit of radius 42,250 kilometers from the center of the Earth. Find its speed if it takes 24 hours to revolve around the Earth. What is its speed? Well, very simple. Speed is distance by time. The time taken is 24 hours. And what is the distance? If it is going in a circular orbit, this is the Earth's center, and the orbit's radius is given to be 42 to 50 kilometers. Right. So that in 24 hours, it goes around once. Starting from here, let us say it reaches the same point in 24 hours. So distance covered is the circumference 2 pi r in kilometers. So 2 pi is 3.14 and 42 to 50 kilometers, and this is hours. So we'll get the answer in terms of kilometers per hour, that is 11,055 kilometers per hour, very high speed. And if you divide this by 3600, you'll get kilometers per second, that is 3.07 kilometers per second, that is 3070 meters per second. Quite a large speed. So that concludes this chapter as well. So please now go ahead and do the questions from your school textbook. And after that, do the assignment, which is available in the course material in this particular course. Also, after this chapter, the next chapter is called Laws of Motion. And once we complete Laws of Motion, then there'll be a unit test on these two chapters, which is that unit test question paper is also available in the course material. Once we finish the laws of motion, then you should do the test. The solution is also given, but don't look at the solution. And the test is of whatever duration given, marks are also indicated. You do the test as per the time given to you. You have to impose your own self discipline, right? And don't look at any books or anything during the test. After the test, you can now look at the solution and grade yourself in terms of how much marks you get. And I also forgot to mention that the first three chapters that we did, namely estimation and units, then measurement of mass, length, and time, and finally experimentation, on those three chapters also there is a unit test. Please do that. Okay, be regular. Okay, guys. So we will meet again in the next session, which is called Laws of Motion.